Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about the case study on audio player. So the audio player is a most recent innovation. So that will be uses this MP3 formats to play the songs or audio tunes. The MP3 file format it will be founded in 1990s. So this is the method of compressing the songs. So we can use this MP3 or MPEG audio layers 3 in one method of compressing audio files. So these methods reduces the amount of storage for that particular audio file. So the file formats that supports is WMA format, that is window media audio, WAV, that is a waveform audio, MIDI, AAC, OGG verbs, ADPCM, ASF, VQF, ATRAC. So these are the some of the standard formats for used in audio formats. So the famous one is MP3. We can alternately we can go with these formats. Each method have different compression techniques. So depending upon the requirement, amount of compression, resolution, and then final output, we can go with this file formats. So the standard format is MP3, or we can use this alternate methods of compression. So all these are a method of compression. The same information can be compressed in different forms. So we need to have the encoder and decoder for this. Encoder converts the raw file into the compressed technique, and decoder decodes that and extract the original informations. So MP3 compression. So this using this MP3 compression system reduces the number of bytes in a song. So while retaining the sound that is near the CD quality. So we need to reduce the amount of memory occupied, but without compromising the qualities. If anytime you compress a song, you will lose some of its quality. So which is the trade-off for the ability to carry more music files in a smaller storage system. Actually, it have both things. So if you try to reduce this maximum possible, it also reduces the quality. So we need to have the trade-off. So we need to have the good quality, and then we need to go with the compression also. So we cannot store a higher amount of memories, because when you are transmitting and storing all the things, it requires the more costlier. So for that only we go for this compression. So the compression should not compromise the quality. So we need to trade off between this compromise of quality and then size. The smaller file size also allows the song to be downloaded from the internet faster. So automatically transmitting the song from one place to another place or downloading, that will be very easy when you go for with these compressions. Consider that an average song about that 4 minutes long. In CD format, it requires a 40 megabytes. But it uses only a 4 megabyte. Look at this, 40 megabyte, it reduces to 4 megabyte. So this is compressed through this MP3 format. So around 10 times we are reducing the size without compromising the quality. See, it reduces the unwanted high frequency component that is not sensitive to human. So we can compress that without compromising the quality. So we can go with a small amount of compromise, but we need to have the quality of the songs. Look at the components of audio player. So we need this data ports, memory, microprocessor, digital signal processor, display, playback controls, audio ports, amplifier, and power supply. These are the major components will be available in the audio player. So data ports, this will be used for communications. So whenever you have this pen drive or some other CDs or something, so we need to feed that song to play. So for that we need this data ports. So we use a different type of data ports. Normally USB will be preferred for connecting that. Memory, for the storing information and the programs, we need the memories. Both the RAM and ROM will be required for that. Also we can use some flash memories also for the holding the songs. Microprocessor, this is the functional unit of microprocessor, or a controller we can say it. So it uses the available blocks. So we have a different blocks. Each blocks will be controlled through this microprocessor, and then depending upon the user commands, that particular operation will be performed by using this microprocessor. So current situation and what are the inputs given by the user and what are the things to be done by the system, everything will be controlled by the microprocessor. This is the heart of the system. So it decides whenever the user presses play button, it starts playing the songs. So that will be decided by the microprocessor. Next one is digital signal processor. See, microprocessor can be capable of doing all the tasks, but if you go for an audio signal, so we need this DSP processor. Because if you, for example, if you want to take a compression or if you want to take a transform from time domain to frequency domain, we need to have this digital signal processor. Because if you have a digital signal processor, we have the dedicated instruction. For example, if I want to take a discrete Fourier transform, I have directly DFT or FFT commands. So similarly, all the compression or audio signal processing will be very easy in DSP processor, but that will be very difficult in a microprocessor. That's why we use this dedicated DSP processor for an audio signal processing. Display units. So normally we use in a 7-segment display or LCD display to display that information. So the informations like which song playing or what are the informations available, that should be displayed to the user for that access. For example, once if they open the folder, what are the songs available inside the folder, that should be displayed so that user can select which songs to be played. Similarly, whenever they're pressing the commands or some other information, that should be displayed to the user so that the user can be friendly access the devices. So for that we use the 7-segment display, or sometimes we can go with an LCD displays in the devices. Playback control, user may sometimes fast forward or select next songs or replay the songs. So these things we required in a playback controls. So user can press the play button or a fast forward or a previous songs or a next song or a next folder. So like that we need to have the different control buttons. So whenever the user presses that particular control button, depending upon that particular functions to be performed. Next will be audio ports. So we are having an audio that should be played. So for that we need to connect a speaker to the system. So for that we need to have the port of audio ports. So different audio ports will be available. Normally that 3-pin jack that may be used for an audio port, or some other ports also can be used. Amplifier. So whenever we have the songs, so we need to amplify it for an high quality, because the song information will be very small. So we need to have an amplification so that will be heard by many people. So for that the amplifier is a basic function of an audio player. So we need to amplify to get a higher voltage so that it can be played for a long distance or many people can be covered with this song play. Similarly, power supply. So this will be used for giving a power supply for the entire unit. Look at the block diagram of this audio player. This first one. So this is the bitstream input. So this will be come from here. So this is the synchronization, CRC check, hub and table and scale factor. So these things will be done here. Synchronization to synchronize the bit stream and the system. We use this synchronization. CRC check is cyclic redundancy check. So CRC check that will be used for whether the data is received correctly or not. So that way error detection and correction code is the CRC codes. And hub and table, normally for compression we use this hub and coding. So for that we need to have the hub and table. Scale factors, sometimes we need to have this scaling of the information. So for that we use this scale factors. Look at this, the output of this will be have these two things. One is a hub and decoding. Why we use two things means we are going to use for two channels. So normally it will be played with the two speakers. So we have a left and right. So for that we need to have a different things. So that's why look at this. Hub and table will be connected for both blocks. Hub and decode will be done for an left side and right side separately. And then next will be re-quantize. So we have quantized the values in the encoding side. So we need to compensate that. That is a re-quantize that values. After that, recording system. So the re-quantized value will be given for the recording, and then that will be a stereo decodings. So after the stereo decoding, actually both will be comes for that. So next will be reconstruction filters, because the decoding it will not be in a smooth manner. So to make that we need to have the reconstruction filters. Look at this. And next will be IMDCT. So this will be for an inverse of that discrete cosine transform. So because we have already transformed that discrete cosine transform, we need to have that reverse operation, that is IMDCT. After that, frequency inversion will be performed to get the original signal, and then after that we have this synthesis polyphase filter bank. So filtering make a correct audio format. So that will be given for the channel. So we have the left channel and right channel, both have the same blocks. So we need to have the different different conditions and things, and that should be performed separately, and that will be given for the particular speakers. Thank you.